Good evening, sir.
Good evening. Hi, how are you doing?
Fine, sir.
Okay. So did you try to solve the question of last time, last class?
Actually, I wasn't able to do it because that time I joined late the class.
Okay,
So
that's why you couldn't. So what topic we studied last time? The parallel combination, right?
yes, sir.
Okay. Further, we have to take some notes of it, okay? So that's parallel combination is clear to you?
Yes, sir.
What is the parallel combination? What the resultant uh, resistance in parallel combination? Oh my gosh. What was the effective resistance in case of parallel combination? Did you solve this problem last time? This one?
No, sir.
Okay, why?
Because I joined late
Okay,
because of net issue.
okay. So you are not aware of parallel combination, or you are aware?
Not properly.
Okay, no problem. We'll recap it in a minute. Okay, no problem. So yes, last time we were 4 to 5 people, right?
Yes, sir.
And today you are only one. So are you aware of series combination? Or you didn't study the series as well? If no harm, can you say me what is the series combination? There is no problem. If you remember, then also you can say. If you don't remember, you simply can say no.
There is R1 and R2. We have to solve that, right?
Yeah, that's the combination of resistors. Okay. Actually, in our daily life, we can connect the loads like fan, bulb, tube light, air conditioning machines in 2 ways. Okay. What are those 2 ways? Either we will connect those loads one by one. For example, this is fan. Okay. This is fan. The fan is two-terminal device. Okay. It is two-terminal device. If this is fan, it is two-terminal device. Same, the bulb. It is also two-terminal device, right?
Yes, sir.
Okay. So either and our battery, yeah, supply. This is also the two-terminal device. This is the battery now. This is also two-terminal. One terminal this side, another terminal this side. So either we can connect with battery. This is suppose a single cell. Okay. And we have to connect these two battery terminals. So we will connect it like that. And we will again from this and this. Can we connect like this? This is one possibility,
Yes, sir.
right? And another possibility is that okay, Madiha, you are back. So how are you doing, Madiha? And another possibility is that this is battery. So here it is fan, right? This is also two-terminal device. So we will connect one terminal to here, and here is bulb, right? This is also two-terminal device. This is bulb. So I will connect one port to here and one port to here, right? This is also the right way of connecting the apparatus, right? This is called series combination and this is called parallel combination. If we will connect end to end through a battery like this, this is this combination. If we are connecting one apparatus bulb, then fan, then this in one wire, as we did over here, and then another with the battery like this. So it will call the series combination. And another that we solve, that the first figure one, this is the parallel combination. Here the potential difference is same, right? So this is two type of combination. Clear? Madhya, what is difference between series and parallel combination? If you don't mind, can you open the camera? So my network is unstable, MK. In Uttar Pradesh, network is always unstable, right? So Zeva is clear to you?
Yes, sir.
So what is difference between series and parallel combination? In series combination, okay, I'm drawing it here, okay. So this is the parallel combination. This is the parallel, P-A-R-A-L-L-E-L, parallel, and this is the series one. Oh, sorry. We are just doing in 1 or 2 minutes. Okay, then we will move to the further topic. I'm waiting for other students as well. So what will be the direction of current? What will be the direction of current? Current will always go from the larger arms. So this is I. This is the load 1. This is load 2. This is load 3. This is series combination. Series combination of resistors. Clear?
Yes, sir.
Okay. So what is the similarity between both? Oh, sorry, what is the difference between both? Yeah, of course, we have to draw series and parallel combination. If you were present in the last class, it's okay. Otherwise, we have to draw. So in parallel combination, the potential difference, the potential over here, this is Vx, and potential over here, Vy. So in parallel, potential remain fixed, P-O-T-E-N-T-I-L, potential between resistor remain same. Okay.
Yes, sir.
But what will be another thing is that if current I is flowing through this circuit, then current will distribute itself. This will be I1, this will be I2, this will be I3. Okay. So the current will be like, if total current is I, then it will be distributed as I1 plus in those second arm I3, in third arm I3. I1, I2, I3. So current will distribute itself in each branch, but the potential will remain the same. And what is similarity between series combination? What will be the situation in this? If current I is flowing through this circuit, so current will be same at each point. Okay, so current will remain same. Current will remains same. Got the point?
Yes, sir.
Or what about the potential? the potential will be different. Here will be V1, potential drop across this will be V1, here will be V2, here will be V3. So in this combination, the bulb, if we are adding 3 bulbs of same size, all 3 bulb will glow with same intensity, right? Same intensity in the parallel combination. In the series combination, the glow in bulb will be very less. The bulb won't glow. The same if I'll do the connection in our room, okay, in series combination, then we won't get the full capacity of our apparatus. Got the point?
Yes, sir.
So our home, we use parallel combinations of loads, right? Everyone draws current from the power supply, every household, and they connect the every apparatus in the parallel combinations. So we already derive in series and parallel. Can we drive the result for the combination of resistors in both cases? We are 5, Zeba, Madiha, and what the next one? Jaslyn. Okay. Jaslyn is very silent. Jaslyn, we did this last time, remember?
Yes, sir.
Okay, okay. What the next one? So can you repeat any of you? Zeba was not present in the last class. That's why I was giving some summary. Jaslyn, you remember each and every step how to calculate the equivalent resistance in all these 2 cases? Do you remember or you forgot?
I don't exactly remember.
If you don't mind, you can open the camera so we can interact.
Sir, can you hear me?
So, Jaslyn, can I proceed to calculate the resistance of each cases in each cases?
Yes, sir. Can you hear me?
Yeah. Okay. So I'm going to repeat the calculations. Uh, in series, we'll do in series. Okay. Uh, combination of resistors in series. Combination of resistors in series. Just I'll use this small space. This is the series combination. Just have a look. This is potential difference across these 2 terminal, capital V, right? And the current passing through this circuit is capital I, right? So what is Ohm's law? Ohm's law is equal to V is equal to IR, right? So the potential drop across V1, so this V will be equal to potential drop across V1 plus V2 plus V3. If we will add all those potential difference, it will come equal to V, right? This is clear? This is the
Yes, sir.
series combination.
Yes, sir.
Okay. So what will be the Ohm's law? V is equal to IR, Ohm's law, OH, Ohm's law. This is V is equal to I time R, right? So for the case of entire potential and current I, this will be capital I times R, R total, R total, okay? R total, sum of all the resistance of this circuit. What will be the potential drop across V1? That will be current is fixed I. Only I current is passing through these all junctions. These are not junction, but all joints I. So this will be V1 will be I R1 plus I R2 plus I R3. Clear? Now take the I common. Take I common. Clear? Take
Yes,
the
sir.
I common and tell me what is the result. Jaslyn, you already saw this solution yesterday, means last time. So solve it for me. What are we getting? This will be I R total. I we gonna common, taking common. So this will be clear. So what we will do, we will just cancel this I with this I. So R total will be R1, R2, R3. Clear?
Yes, sir.
This calculation is clear to everyone?
Yes, sir.
Okay. So what does it means? In series combination, the equivalent resistance of circuit will increase or decrease. In series combination, the equivalent resistance or total resistance of a circuit will increase or decrease.
Increase.
Okay, so it will be increasing only. This is true for n number of resistance. This is also the point to be noted. This is true for n number of resistors. This is true for n number of resistors, right? N number of resistors means R total will be equal to R1 plus R2 plus R3 dot Rn. Clear? If we have n number of resistors, say 100, and all are connected in a series, then we will just add all resistance R1, R2, R3 to R100. Clear?
Yes, sir.
Yes, sir.
So now come to the parallel combination of resistors. What is this? Here we see that potential is fixed. Potential is fixed, only current is being distributed. So there is no much difficulty in solving this. So I already written this I1, I2, I3 using Ohm's law. What is Ohm's law? Ohm's law. V is equal to I time R. So I will be nothing but V over R, right? Clear?
Yes, sir.
Where V is the total potential across the battery, and capital I is the current passing through this circuit. Clear? So just put these values and see. This I, the total resistance, total current, it will be equal to V over R. This will is equal to what? Potential is fixed, only resistance is being changed. Clear? This is all RV. Why this is all RV? Because we know that potential across the circuit, this resistance, it doesn't change, right? Here the current was fixed. In this case, current was fixed. Here the potential is fixed. So potential is only V, that is V, right? If we will apply a voltmeter and measure the potential across it, it will come only V. Only current is going to be distributed among the branches. So now take the V common. Take V common. So this will be V over R. This will be V 1 over R1, 1 over R2 plus 1 over R3, right? So now this V will be cancelled. So what will be the total resistance? This is R total. Okay, this is R total. Total. So either don't write the total right now, just write it. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Is clear?
Yes, sir.
So how we will find the equivalence? Is we have to find the equivalence for two resistance only. For R1 and R2 only in parallel. It means that this is R2, this is R1, this is connected like this two is connected together, and then we have to add it to the battery. Current will flow, the direction of current will be this. So R equivalent in this case will be 1 over R will be 1 over R1 plus 1 over R2. Clear? So we will take the LCM. So this will be R1, R2 multiply and R1 plus R2. This will be 1 over R, right? So R equivalent we will write. This will be R1, R2 divided by R1 plus R2. Clear?
Yes, sir.
Is clear to everyone, Madiha, Jaslin, and Ziva?
Yes, sir.
I did this repeated calculation. Madiha has network problem. Yes, sir. So you may write it down, okay? So from here, from this series combination, you just write it down. Once you are done, let me know. Okay. Jaslyn done, Madiha, Zeba, if you all are done,
Done, sir.
Madiha done, Zeba are done. Now we will somehow try to elaborate these things, okay? So let me go through. One question is over here. So how many of you solved this question last time? How many of you solved this question last time? Jaslyn, I think.
Yes, sir. We did.
Zeba, you try this question now. Okay, Madiha, you did. So Madiha, for you, I have another question. If you did, then I have another question for you. I was remembering some good questions, but so now for you, we have a circular wire, okay? And this is being connected at the two ends. If resistance is the resistance of this circular wire is the resistance of this circular wire is R, R ohm. Then find the equivalent resistance across A, A and B, across A and B. The resistance of this circular wire is R ohm. Then find the equivalent resistance R across A and B. Question is clear? Nadia, question is clear? Yes, sir. Then solve it for me. Jaslyn, you also solved this question last time. So you also solved the question that circular portion wala.
Okay, sir.
Okay. Question is clear to you?
Yes, sir.
Okay, then solve it.
So what is written after wire?
Circular wire is R ohm. Circular
Okay,
wire
sir.
is R ohm. Okay. R ohm. What about Zeba? Did you solve the question 11.7? You guys are not opening your videos. Okay. So it's tough to understand who is working and who is not. Zebra is left. Nadia and Jesslyn, did you get the answer?
Sir, can you explain the question?
Nadia and Jesslyn, did you get the answer of your question? What? I didn't understand the question. Yes, it's Jesslyn problem. No problem, Jesslyn. I'm going to see what is the question. A wire of resistance R, a wire of resistance R is bent in a form of circle. So a wire of resistance R O is bent in circle. Okay, circle of radius R. Now what we have to do? Oh my gosh, I'm the bad teacher. After class, I didn't clean the board, whiteboard. That's why I'm the bad teacher. So a circular wire of resistance R ohm is bent in a circle. Then find the R equivalent across its diameter. This will be the diameter across its diameter A and across its diameter A and B. A wire of resistance R is bent in a circle. Okay. Then find the R equivalent across its diameter, that is A and B. Now question is clear? Jesslyn, now is
Okay,
clear?
sir. Yes, sir.
Now find the R equivalent. Nadia, did you get the question? So what is the R? R is directly proportional to length, right? Jaslin and Madiha. So this is the circular loop. This circular loop, if we will stretch it, this is A and this is B. So if we will stretch it, it will be like this, right? Clear?
Yes, sir.
So if you now it that along the diameter, the length will be half. If length will be half, so resistance will be also half. Clear? It is clear or not?
Okay, sir.
R is directly proportional to length. So it is now if you are reading it across it diagonal, so it means that this circle is now the circular loop will be half half, or circumference will be half half. If the circumference of all the circle is 2 pi r, so semicircle it will be only pi r, right? So now you can say that it is half of it. Clear? Now you have to find the equivalent resistance in the similar way. Like that, R equivalent will be 1 over R1, R1 into R2 divided by R1 plus R2. This is the same that we used earlier. Clear?
Yes, sir.
So now you have just solved this equation. Nothing else. Just solve this equation. This is product sign, not the minus sign. So I did a mistake. Let me rewrite it. Here R equivalent will be R1 times R2 divided by R1 plus R2. This is the R equivalent for two resistance in parallel. Clear? You guys are taking time a lot. What is the answer of it? What is the answer of it? Four. What about the other one? This was from Jaslin. What about Madhya? What will be the R equivalent? What is the R equivalent? Tell me the value of R equivalent. First of all, you guys have to switch on the camera. I'm just asking you and there is no response. I'm not aware where you are, whether you are here or you left. So make sure from next time. Jaslyn, can you do the calculation again? Do in the proper way. I think it's wrong. getting answer. No problem, no problem. Madhya is not here. I will remove you. You are not responding. So see, what is R1? R1 is R by 2. R1 is R by 2 and R2 is again R by 2. Clear? What will be the denominator? R by 2. This is R by 2 plus R by 2, right? So now now solve it. Now Jaslyn, solve it and see how the result. Now solve and show me. I can't start the new topic. It was just the yesterday one, last time one. I thought of starting new topic, but you guys are struggling with problems. Jaslyn, can you do this sum? Madiha, do this sum. This is not half, dear. R by 2, this will be R square by 4. Clear? And this R by 2 will be nothing but R. So 1 R to 1 R cancel. This will be 1 over 4 R. Got the point? It will be 0.25 R. This is more. Clear? Zeba, did you get the answer for your question? Now it's clear? Madiha and Jaslyn. So now for Madiha and Jaslyn, we have some further question. The question is that we have to find, I think you all solve these question, right? So now we have question to find the current in each of the resistors. Okay. So suppose this is R1 and this is R2 and it is being connected to a battery of potential V and current I is going to this circuit. Sorry, this is I0. In this circuit, it will be I2. In this branch, this will be I1. Current will distribute itself in two branches, right? So if we have to find the value of I1, it will be nothing but R2 divided by R1 plus R2 into I naught. Current through current through I1. Clear? The value of current through R1 will be this, and through I2 will be R1 divided by R1 plus R2 time I naught. Clear? We don't have to
Yes.
find the expression for it. It is beyond the syllabus, but the direct results we can know. Okay, so the current I is going from this terminal. This is the resistance R1 and R2. So it will be distributing like that. So for example, I am giving you this question. Question is, this is the question. This is R ohm, and this is also the R ohm. This is connected like that. And this battery is like this. Current is I ohm, sorry, I ampere. This will be I1, I1. This will be I2. And this is I naught. Then find the value of, this is V volt. Then find the value of I1 only. Only you find the value of I1. Okay. So once
Okay,
the
sir.
I1 is solved, we will further do I2. Deba, you are just coming and going. Did you solve that question? Kindly try to on the camera from the next class. First of all, we have to find the R equivalent. That will be R1 into R2. That is R1 into R2 divided by R1 plus R2, right? So this will be R by 2. Clear? This is
Yes,
clear?
sir.
Okay.
Yes, sir.
So if I have to find the current in loop 1, so what we will be doing? I'm just removing some part. Did you note it? Jaslin, did you note
Yes.
the earlier part?
Yes, sir, I did.
Okay, thank you. Actually, question is easy, just we have to use the definition. Okay, so I have to find the I1. So what I will be doing, I naught into, this is R divided by, what will be this? R1 plus R2. Sorry, this is R equivalent is R1 plus R2. R1 plus R. So this will be I naught over R divided by 2R, right? So if see, I1 will be, I1 become I naught by 2, right? Clear? So we know that I naught is equal to I1 plus I2. Clear? We know the
Yes.
I1, so we can calculate the I2, right? If we know I1 and we also know somehow I naught is fixed, so we can find the I2. I2 will be I naught minus I1. So I naught is I naught and I1 is I naught by 2. So again, it is I naught by 2, right? So if
Yes.
resistance is equal, so current will be distributing half in each branch. Okay, so now see. So now test. I naught will be what? It is sum of I1 plus I2, I1 plus I2. So I naught is I naught by 2, I1 is I naught by 2, plus again, I2 is I naught by 2. So this will be I naught. So this is the conservation of current. Okay. The amount of current entering at this loop, the same amount of current is exiting out over here. Clear?
Sir, can you explain the last part?
Okay. So the last one is that we already say that if current I is entering in this loop, that will be equal to sum of I1 plus I2 equal to I naught, right?
Yes, sir.
So the all current was I naught. So it is being distributed in these two loops, I1 plus I2. So sum of I1 plus I2 will be I naught. And we already find I1 and I2. So if we will put the all values over here, we must have to get the I naught. So we are getting I naught. Clear?
Yes, sir.
So write it down. Concept is clear. Any doubt?
No, sir.
Okay, then do it. Note it. Today again, two students were not present. Next time again, they will ask her redo those calculations, right?
Yes, sir.
Again, we will be doing it for them.
Finish, sir.
Done?
Yeah.
Okay, so one point to note again. See, in the parallel combination, the R equivalent is less than the least resistance. Okay, so this is R by 2 and we have the resistance R. So this is half of R. So in parallel, the equivalent resistance reduces. Clear?
Okay, sir.
So how, if I will ask you again, what does it mean? So let me show you again. Are you not feeling sleepy?
No, sir, it's 9 o'clock here.
It's 9 o'clock there. Okay. It's 9 o'clock and here is 10 and a half. From where you are speaking?
Sir, Dubai.
Sorry. From where are you speaking? This is 2 ohm. This is 5 ohm, right? So find the R equivalent for this circuit. Find the R equivalent. Can you find it? So R equivalent, find it. R equivalent will be the product of two resistance divided by sum of two resistance, 0.7. Okay, so let me do product of two resistance 2 into 5 divided by sum of two resistance 2 plus 5. This is 10 over 7. Oh, Jaslyn, you are wrong. R equivalent is just, you did mistake. R equivalent will be 1 over R is 1 over 2 plus 1 over 5. Dear, how you are doing? 5 plus 2 divided by 10. This is 1 over R. So if we will write it R, then it will be 10 over 7. Then it will be, R will be equivalent will be 10 over 7 as we did over here, right? So you did mistake. You got the mistake? Ten over 7 will be 10 divided by 7. So it is 10. 7 ones are 7. It is 3.30. 7 4 is 8. 1.4. Okay, sir. So make sure your calculation error, minimize the calculation error. So R equivalent is how much? 1.4 ohm. So see, R equivalent is less than the least resistance. So 2 is the least resistance, 5 is the maximum resistance. This is the smallest resistance. So in parallel, R equivalent is less than the smallest resistance. So smallest is 2 ohm and we are getting R equivalent 1.4. This was one of the point I wanted to note it